Okay, so today we're going to be naming alcohols. Now, naming these molecules is really very similar to the way you've named other molecules before. You're going to be using exactly the same naming convention. The only real difference about alcohols is the suffix that goes on the end. You've seen different suffixes for different molecules, and alcohols are no different. The suffix for an alcohol is actually very simple. Al, just meaning alcohol. All right. And as you've seen before, there is a three-barrel naming convention for these molecules. The prefix, which indicates what substituents you have there, chloro, methyl, bromo, that sort of thing. The parent name, which you've seen before, which is the longest carbon chain containing the functional group of interest. And then the suffix, which tells you about what functional group is of dominance. Okay, in this case, it's all for alcohol. So let's start off with a very simple one, following this prefix, parent, suffix business. 4 carbons, you know 4 carbons is butane, all right? And we just take the term butane. There are no prefixes here because there are no substituents, and we simply put all on the end. Now, the only thing that we need to be careful about here is if I just write out butane, like so, all right, and you'll notice that the name of this molecule actually isn't butanol, it's butanol. So something happens to this E, and literally all that happens is that it gets chopped off, and the rationale for that is it's really quite simple. If you have a suffix that starts with a vowel and your name ends in a vowel, because in the English language we don't really know what to do when we put 2 different vowels together, we just lop off the last E and replace it with whatever the first letter of the suffix is. So in other words, butanol. The only thing that you need to do to finish this name off is just to put down the location of the alcohol. It's on carbon number 1, so therefore the name of this would be 1-butanol. Right. So when we move over to this second molecule here, you can see this is really exactly the same. It's just a little bit more complex. So if I was to ask you, well, what's the parent name? Well, you'd say, okay, well, there's 2, 4, 6, 7 carbons, so the parent name would be heptanol. It seems simple enough. The alcohol is on carbon number 3, so that would be 3-heptanol. But then, of course, you have these 2 things, the methyl group here and the methyl group here. Now, we know these are methyl groups. If there's 2 of something, we use the prefix di. And if we want to recognize where exactly those methyl groups are, we just look at the carbons, and you can see it's carbons 3 and 4. So therefore we would call this 3, 4, di, oops, get my pen back, 3, 4, di, methyl, alright, and then we need our 3-heptanol. So we're just coming up with a name here. And you can see once again, this is following our triple-barreled naming convention. We have the prefix, we have the parent name, and we have the suffix. And notice that's the location number for each of our species, with the comma separating numbers, the hyphen separating numbers, and text. Okay. All right, let's move on to something else. Look at something a little bit more complex. What if we had this alcohol here? It looks very similar to the last ones, except we got something to take into account here that we didn't have to last time, and that's stereochemistry. So if the stereochemistry wasn't here, hopefully you could figure out, well, this is there's an alcohol on carbon number 2, so therefore with a 5-carbon chain that would be 2-pentanol. But we need, if we have the wedge in the dash here, to actually specify what that stereochemistry is. In this case, we're talking either R or S. So let's just look at some priorities, okay? We're looking around this carbon, so the biggest atom coming off that carbon is, of course, the oxygen, priority number 1. If hydrogen's present, it's always the lowest priority. And you can see a propyl group is bigger than a methyl group, so therefore that gets priority 2. That gets priority 3. The lowest priority group is already pointing away from us, so we just go, well, which way around do our substituents go? 1, 2, 3. Well, you can see they go around clockwise, which means that is R. In other words, the whole name of that would be R2-pentanol. Okay. Now, when we move over to this one, There is one thing about this molecule that makes it look, or makes the naming of this a little bit more complex, and I'm putting the circle around this bit, and it's this piddly little thing right here. The double bond might not seem important, but it does have an important factor on how we name this molecule. We know that we can name the chlorine just as a substituent, which is fine. We know the alcohol is going to be OL at the end, so the chlorine is going to be our prefix, the alcohol is going to be in our suffix, and we have our 2, 4, 6 carbon parent chain. So if that double bond wasn't here, hopefully you can see this would be 3-chloro, 2-hexanol. Alright. So we have our 3-chloro. Yeah. We have our alcohol on carbon number 2, so this would then become 2-hexanol. But we have one more thing as well, and of course that is the alkene, which is on carbon number 3. So we have our alkene starting on carbon number 3. Now I can't just say 3-ene, we need to take it into account in the parent chain somewhere. So what that means is we go from hexanol, because that talks about hexane, and because this isn't hexane, this is hexene, this goes from hexanol to hexenol. In other words, 2-hexenol. So if I just write out here 2-hexenol, can anybody see what the problem is with this? Well, if you haven't recognized the problem, well, what the problem is, you have a 2 here, and the question that you're going to be asking yourself is, well, does the 2 refer to the ene, or does it refer to the ol? And that's the problem. If you name something this way, you always want to make sure that you put the number directly before the species that you're talking about, its location. So, in other words, we want a 3 before the ene, a 3 before the chloro, and a 2 before the ol. So what that means is if we put all this together, we're going to have our 3-chloro. So let's just get that out here. All right. 3-chloro. And then because our alkene comes first, we're going to put that number first as well. 3-hexene, again hex because it's 6 carbons. And then because we only have one more place to put the location of the alcohol, we're just going to put that right before the ol. That's quite a long name there, but you can see still, it still conforms to the 3-barreled naming system. The prefix, the parent name, and the suffix. It's just that the parent name is a little bit more complicated because of the fact we have the alkene there. Alright. Okay, let's move on. If I can get this to work, please. Alright. Let's talk about cyclic alcohols, okay? And these are slightly different in how we name these. Okay? The only real thing that makes these different is that we always assume one particular thing when naming cyclic alcohols, and that is, no matter what the alcohol carbon, the carbon bearing the OH, is always assigned carbon number 1. It's like it's the top dog in the molecule. No matter what the molecule looks like, no matter what else is on there, Dwayne Johnson could be standing on here. The fact is the alcohol carbon still has assignment number 1. And then you just name a number all the other substituents relative to that. So if we look at our parent chain here, in this case it's actually not a chain, it's a ring, so our parent name here would be cyclohexane, or in this case cyclohexanol with the alcohol there. And then of course we have a fluorine on carbon number 2, and we have this guy on carbon number 4. Okay. Now one thing you might be asking is, well, hold your horses there, Dr. P. Why did you number that way? Why don't we do this? Why can't we number around 1, 2, 3, 4, and 5? Why can't we number around in green like this? Well, we can, but if you remember, whenever you're naming like this, you want the lowest possible total of all your substituent numbers. So you got to decide which way around you're going to go. 1, 2, and 4 add up to less than 1, 5, and 3. So therefore that means the 1, 2, 4 blue route is the way we go. Now, we saw on the last slide that chlorine as a substituent was chloro, therefore fluorine, as you would expect, becomes fluoro. But what's this? You can see how many carbons there are here, and there are 3, which suggests propyl. But also notice that it's not connected on either end, and that's what you would expect for a propyl group. It's actually connected in the middle, which actually says, well, maybe that's an isomer of propyl. Hence the term isopropyl. Whenever you see isopropyl alcohol, it's the rubbing alcohol stuff you buy in the brown bottle that you get for about $1 at Walmart. Stuff you can use, well, for all sorts of things. Isopropyl. And then all we have to do is figure out how we arrange these. Well, we just place them alphabetically. Okay. So the parent name, we've already said, is cyclopentanol. And so then we have the question, well, which one comes first? Does the fluorine come first, or does the isopropyl come first? Well, we just want to ask ourselves, well, which is first alphabetically? And of course, it's fluorine. So therefore, the full name of this would be 2-fluoro, 4-isopropyl, cyclopentanol. Notice I did not put a 1 in that name anymore. Let me see if I can write that out. We said that was 2-fluoro, okay, 4-isopropyl. I'm just going to write this out underneath here, simply to prevent myself running out of room. Cyclopentanol. You remember I said we did not put a 1 for the alcohol because it is assumed to be position number 1. And if we know that 2 and 4 are the positions of the fluoro and the isopropyl respectively, then we know that 2 and 4 must be relative to something else, and that something else is, of course, the alcohol. So it's always the way when you are naming cyclic alcohols that you assume this is carbon number 1 and you don't put it in the name. Now this molecule, you can see, is really very similar, except it's cyclohexanol and not cyclopentanol. The only real difference is it's a little more complex because of the stereochemistry. So let's see if we can figure this stuff out before we go any further. Let's look at some priorities for this carbon here. All right, chlorine's priority 1, hydrogen's priority 4. We know that coming off this carbon. So when we look at the 2 carbons coming off here, well, carbon, carbon, I can't make any difference there, so I move to the next atom, carbon, carbon, and I still can't make any difference. So then I move to the next biggest atom, carbon, oxygen. Now because oxygen is bigger than carbon, that means that this group has priority over this one, which means this becomes priority number 2, and this becomes priority number 3. So therefore, that makes this carbon center have S stereochemistry. All right. Now let's see if we can do the other one in a different color to avoid any potential confusion. So that's this carbon that we're talking about. We always know, as we said before, if hydrogen is present, it's always the lowest priority. And let's look at the other 3 carbons coming off there, which is this one, and this one. Well, this only has 2 carbons, so this is going to be the smallest out of the bunch. It's going to have the second lowest priority, but we want to compare this one and this one. Well, those 2 carbons are the same. This carbon and this carbon are the same, but then we have oxygen and chlorine. And if you look on the periodic table, chlorine is bigger than oxygen, so therefore chlorine gets priority. In other words, this becomes priority 1, this becomes priority 2, and we go around 1, 2, 3 in a counterclockwise fashion, which suggests this is S, but if you hold your horses for just a minute, you'll notice the lowest priority group is actually pointing towards us, and we know it actually should be pointing away from us. So here's a little trick. Whenever you have the lowest priority group pointing in exactly the opposite direction to the way it should be, assign your priority and then simply flip it. So 1, 2, 3 suggests this is S, but because we flip it because of where the hydrogen is, it simply becomes like Johnny Depp in Pirates of the Caribbean. It becomes R, little parrot on your shoulder. Maybe R and S. Okay, so let's try and put all this together. Well, we know the parent name here is cyclohexanol. The chlorine is on carbon 3. You know what, I'm going to erase some of this stuff here for just a minute. In fact, now we have this stuff sorted out and we know that's R and S. Alright. Just put this back on here. We said that was R, that was S. We know the alcohol's on carbon number 1. The chlorine is going to be on carbon 3, and the ethyl here is going to be on carbon 5. But okay, let's hold our horses once again, because why couldn't we name it this way? Why can't we have the ethyl on 3 and the chlorine on 5? All the numbers are the same, 3 and 5 in each case. It's different than what we had over here. These two number totals are the same. So what do we do when we have this situation? Well, it's actually really quite simple. If we can't choose either way based on the number total, we simply put the lowest number and assign it to the first group that comes alphabetically. So in other words, chloro comes before ethyl, so the 3 goes with the chlorine. In other words, 3 chloro, 5 ethyl, cyclohexanol. All right. And the only thing we have to remember about this is because we have the 2 stereocenters, we said chlorine being number 3, that is 3S, and we said the ethyl, or the stereocenter around that ethyl carbon, is R. So 3S, 5R, 3 chloro, 5 ethyl, cyclohexanol. Notice once again we don't put the 1 for the alcohol. Alright, let's move on once again. We have a few more structures to look at. Alright, now this one, this is an aromatic alcohol, and if you remember from chapter 8 from last semester, certain groups around a benzene ring change the parent name of that benzene, and if you remember, an OH is one of those, and if you also remember what that name changes the parent name to, it changes it from benzene to phenol. Now one thing that a lot of people get confused about is the difference, or they don't see the difference, I should say, between these two. Phenol, and then the term phenyl. Now these two actually mean 2 different things, and they are not interconvertible, okay? Phenol is this, benzene ring with an OH on it. Phenyl, on the other hand, and this is really important, a phenyl is when you name a benzene ring as a substituent in a molecule. 2 big differences. Okay, so we'll get to the phenyl here in just a minute, but if you remember what the name of this group is, it's nitro, and if you remember the relationship of these two, these are para to each other, so therefore the full name of this will be para-nitrophenol. Alright, so let's move over to this guy. Why are we naming the benzene ring as a substituent here? Well, it's actually all to do with the length of the carbon chain versus the carbon substituent. The rule that we saw earlier on last semester was if the chain is larger than the ring, the chain is the parent name, the ring is a substituent, and vice versa if the ring's bigger. So here the chain is 7 carbons, the ring is 6, so therefore the ring is named as a substituent. The species that has priority, as always here, is the alcohol. Alright, so we just need to name everything relative to that. So this would be 2-heptanol. You can see the bromine's on carbon number 4, the phenyl is on carbon number 5, so therefore this would be simply, because bromine comes first, 4-bromo, 5-phenyl, 2-heptanol. Alright, so phenyl versus phenol, an important difference. And the very last thing here that I wanted to touch on is what happens when we have 2 alcohols in the same molecule. If you remember the prefix for a substituent, when there's 2 of them, that prefix is di. Dimethyl, dipropyl, di whatever. Well, you will probably not be surprised to hear that that same prefix is true if you have two alcohols. If the suffix for an alcohol is "-ol", then surely the suffix for two alcohols is "-diol". And would you think you need a number locator for each of the alcohols? Well, yes, of course you would. There would be no rules as to why not. This would be on carbon 2, this would be on carbon 3, and you can see the parent name here is pentane. So simply put, 2, 3, pentane. We're exactly following our same naming convention here. The only difference is the suffix in this case does not begin with a vowel. It begins with, in this case, a consonant, or that consonant is D. So therefore, we do not need to lop off the last E from pentane. So therefore, the full name of this becomes 2,3-pentane-diol. All right, so let's just summarize here. We have figured out how to name diols. We've figured out how to name aromatic alcohols and the difference between phenol and phenyl. Phenyl, of course, being benzene as a substituent. Okay. We have also talked about cyclic alcohols, how to name those. We've talked about relatively complex alcohols with double bonds in them, alcohols with stereochemistry, and then we talked about some basics too. And that, in a nutshell, is how we name alcohols.